Solving triangles is what we call finding all missing sides and angles in a triangle. So solving a triangle means finding all unknowns for that triangle. This will involve using all three of our primary trigonometric ratios. Remember, those are sine theta, which is the length of the opposite side divided by the length of the hypotenuse, cosine theta, which is the length of the adjacent divided by the length of the hypotenuse, and tan theta, which is the length of opposite divided by length of adjacent. We often shorten this to remind ourselves to SOHCAHTOA. It's worth writing down. It's also going to use two other ideas that we have met previously in previous years. The first one is that all angles in a triangle add up to 180 degrees always. So the three angles in a triangle add up to 180 degrees. For a right angle triangle where one of those angles is 90, that means 90 degrees plus two other angles equals 180 degrees. So for example, it would look like this. The second thing that we're going to use is the Pythagorean theorem. You should be familiar with this one by now. A squared plus b squared equals c squared. And this is when we're going to use to find the length of a third side if we have two sides already. So remember, c is the hypotenuse, always. And so the three versions of this are a squared plus b squared equals c squared, or c squared minus b squared equals a squared, or c squared minus a squared equals b squared. I always just use the first one and do algebra. It's easier to remember. Now, this is critical. Whenever possible, use only original data that is given to you in the question, not things you find. So let's look at an example of solving a triangle. Got a triangle here. And I'm going to know two things about it. In this case, I know two of its side lengths. So the things I want to find x, alpha, and beta. So I'm going to start by finding alpha. So to find an angle, I'm going to label the triangle, and I'm going to label it compared to alpha. So the opposite and adjacent depend on which angle I care about. For alpha, this is my setup. And so I have the opposite and I know the hypotenuse. So to find this angle, I'm going to use sine. Sine alpha equals 18.6 over 22.1. I use sine because those are the two sides that I know numbers for. 18.6 divided by 22.1 is 0.8416. And now I use that inverse sine, that sine minus 1, to find alpha. So alpha equals 57.3 degrees. Now I'm going to find beta. This is going to involve relabeling the triangle, because opposite and adjacent depend on which angle I care about. So now I'm going to label them in green for beta. Hypotenuse is always the hypotenuse, but opposite and adjacent depend on which one we care about. So I know the adjacent and the hypotenuse now. So I'm going to use cosine. Cos beta is 18.6 over 22.1, and that should look like a familiar setup, except this time it's a cosine instead of a sine. Use the inverse to find this angle. And beta equals 32.7 degrees. Now, one of the ways that I can check myself is I can make sure now that alpha plus beta plus 90 makes 180. That's a check for myself. So now I have one more thing to find. I need to find x. So to find x, I have two sides. So I'm going to use one of our two extra things that isn't a trig ratio. I'm going to use the Pythagorean theorem because I have two sides. I don't want to use one of the angles that I have found in case I made a mistake. A squared plus B squared equals C squared. You can use the pre-rearranged formula. I always just put in stuff. But in this case, I am trying to find one of the sides. I'm going to call it B for no good reason. So 18.6 squared plus x squared equals 22.1 squared. I find those numbers. Algebra to get the x squared by itself. And that gives me 142.45. Then I square root both sides. Remember, that's an x squared, and I want just x. So I have to square root. So x equals 11.9. So I used some trig ratios to find my angles. I used Pythagoras to find an unknown side. Let's look at another one. Solving the following triangle. Now there's two possibilities for solving triangles. Either you know two sides and are missing two angles, or you have one side and one angle. So I'm going to start by finding theta. I have two of the angles already. I have the 90 degree and the 66. So I'm going to use the fact that all angles in a triangle add to 180. The sum of angles rule. So 90 plus 66 plus theta equals 180 degrees. I'm going to put together things that I can. So 90 plus 66 is 156. And I'm going to subtract 156 from both sides to get theta by itself. And I find that theta is 24 degrees. Now I don't like writing them onto the triangle because then it confuses me about what information I have. And I always want to use the original data. Now luckily in this case, since I only have one known angle, my labeling is going to stay the same for finding both sides. So to find y, that's the opposite, and I have the adjacent. So opposite and adjacent uses tangent. So tan of 66 degrees equals the length of the opposite y over the length of the adjacent 5. I'm going to find what tan 66 is on my calculator. And y divided by 5. Get rid of the fraction by multiplying by the bottom. And I find 11.2 equals y. Now I want to find z. The labeling doesn't have to change because I still only know the 66 degrees for certain. So opposite, adjacent, and hypotenuse stay the same. But since this time I care about the hypotenuse and I have the adjacent, I'm going to use cosine. So find cos 66 on my calculator. I'm going to clear the fraction by multiplying by the bottom. Divide by the coefficient in front of the variable. And I'm left with z equals 12.3. So notice that I can find sides and angles only using original data in every case. So we're going to try a couple. Solve the following triangles. Okay. I'm going to label the triangle. And this is going to be consistent because there's one known angle there. So I'm always going to be using that 41 degrees. We're going to start by finding theta, our unknown angle. To do that, I'm going to use that sum of angles. And I end up with a bit of algebra, finding that theta equals 49 degrees. I'm going to find y. Y has the adjacent, and the only side that I know is the opposite. So I only want one unknown per equation. Adjacent and opposite uses tangent. And then I'm going to clear the fraction. And divide by the coefficient in front of my variable. And y equals 4.6. And last thing to find is z. So I only have one known side. It is the opposite, and I want the hypotenuse. So I'm going to use sine. Sine of 41 is opposite over hypotenuse. Find sine of 41 on my calculator. Clear the fraction by multiplying by the bottom. I'm left with 4. And z equals 6.1. All right, let's find one more triangle. Let's solve one more triangle here. Okay. So we're missing 3 things, as we always will be. Let's label this triangle as much as we can, and that's the only thing we can consistently do. So to find alpha, we're going to label the triangle from alpha's perspective. I have the opposite and I have the adjacent. So I'm going to use tangent. Okay, I find what that ratio is, and then I use the inverse function, that -1, to find alpha all by itself. And I find that it is 47.6 degrees. Now I'm going to try to find beta. Label the triangle. What sides do I have? I have the opposite and the adjacent again. So I'm going to use tangent again. So tan of beta equals 0.9143. Take the inverse tan. Take the inverse tan. And beta is 42.4 degrees. Now I need to find one last thing. I need to find x. To find x, I have two sides, and so I want to use Pythagoras. Plug in the sides that I know. I get their numbers. I add them up. And then I square root. And that leaves me with x is 4.7, which makes sense. This is the hypotenuse. It should be longer than the other two. So your homework for this section is the worksheet and section 8.1, page 307, number 3. The more practice you get on this, the stronger your trigonometry overall, because this uses every single part of trigonometry in one question.